Have you ever seen those heartbreaking news reports of devastating floods and landslides wiping out entire communities? It's truly terrifying. And while we often blame heavy rainfall, a major and often overlooked culprit is deforestation. So, how exactly does cutting down trees lead to such catastrophic events? Let's dive into the science. It all starts underground with the tree's hidden hero, its root system. Imagine the soil under a forest as a massive, intricate net. The tree roots, big and small, weave through the soil, binding particles of dirt, sand, and rock together. This creates a stable, porous structure, almost like a sponge. These roots act as natural anchors, holding the earth firmly in place, especially on steep slopes. When we remove the trees, we essentially cut this net. The soil loses its structural integrity. It becomes loose, unstable, and incredibly vulnerable. Without the roots to hold it together, it's just a pile of dirt waiting for a disaster. Now, let's look up at the treetops. The lush canopy of a forest is more than just a pretty sight. It's a powerful, natural umbrella. When it rains, the leaves and branches act as the first line of defense. This process is called interception. A significant portion of the rainwater never even reaches the ground directly. It lands on the foliage, and from there it can drip slowly down, run down the trunk, or even evaporate back into the atmosphere. This interception process dramatically slows down the rainfall's impact. Instead of a torrential downpour hammering the ground, the forest canopy transforms it into a gentle, distributed shower. This gives the soil plenty of time to absorb the water. So, what happens when the trees are gone? Two disastrous things occur simultaneously. First, without the canopy, rain hits the bare ground with full force. It's like turning a gentle shower into a fire hose. This high-impact rainfall dislodges loose soil particles, a process called splash erosion, and begins to wash them away. Second, and more importantly, the ground itself changes. The soil, which was once a porous sponge thanks to the tree roots, becomes compacted and less absorbent. Think about pouring water onto a brick versus pouring it onto a sponge. Without the root channels and the healthy soil structure they create, the water can't soak in. This is what we call reduced infiltration. When the ground can't absorb the water, where does it go? It has to go somewhere, and that somewhere is across the surface. This is surface runoff. Instead of being slowly absorbed into the groundwater, the rainwater rushes across the land, picking up speed and volume as it goes. Small trickles quickly merge into powerful torrents, carrying away topsoil, sediment, and debris. These overloaded streams and rivers can't handle the sudden, massive influx of water. Their banks overflow, leading to the flash floods that can inundate homes and farmland in a matter of minutes. On hillsides, the situation is even more dire. The combination of loose, unanchored soil and a massive volume of water creates a deadly recipe for landslides. The water-saturated soil becomes heavy, unstable, and essentially turns into a liquid mud. Gravity takes over and entire sections of the hillside can give way, sliding downhill as a destructive river of mud, rock, and debris, burying everything in its path. So, the next time you see a forest, remember it's not just a collection of trees. It's a complex living system that acts as our planet's natural flood and landslide defense. The roots are the anchors, the canopy is the shield, and the soil is the sponge. By protecting our forests, we're not just saving trees. We're protecting our communities, our homes, and our lives from the devastating power of water unleashed. The science is clear. More trees mean less risk. Thanks for watching. If you found this explanation helpful, please give this video a like and subscribe for more deep dives into the science that shapes our world. See you next time.